So the first section of this quiz review is just evaluating limits using your graph. Now remember, it doesn't matter what actually happens at the value. You are looking at what y is approaching as you get close to that value. And so the first thing you're going to look at is what limit are they looking for? They are looking for the limit as x approaches 1. And so as x approaches 1 here, I'm going to find where my x value is 1. My x value is 1 right here. So what is my y value doing? Well, if I head from the left-hand side, my y value is moving towards this hole in the graph. And as I move from my right side, my y value is approaching this hole in the graph. So this hole in the graph is at y equals 1. And so my answer here for the limit as x approaches 1 is going to be 1. Now number 5 is a little bit different. You'll notice that on number 5 you have this little tiny plus sign here. That indicates that you are looking for a one-sided limit. Specifically here, you are looking for a limit from the right. Remember, the plus sign indicates a limit from the right. A negative sign indicates a limit from the left. And so as x approaches 0, well, x is 0 right here on the y-axis. And so if I'm coming from the right-hand side, my y value is this right here, and it is approaching that 3, where that particular hole is. And so my limit as x approaches 0 from the right-hand side is going to be 3. Now the next section is evaluating limits algebraically. The first thing you want to do is see if you can just plug it in. If plugging it in does not cause a problem, then you just want to plug it in and that's going to be your answer. And so for this particular one, they wanted as x approaches 2. Well, if I plug in a 2 in the denominator, I do not get a 0. So that means this is not going to cause a problem. So I can just go ahead and plug in that negative 2 and evaluate what this is going to be when I plug in a negative 2. And so I'm just going to add these and simplify the numerator and the denominator. Negative 2 squared is positive 4, minus a negative 2, that's plus 2, and then we have our minus 12, and then we have negative 2 plus 3. 4 plus 2 minus 12 is negative 6. Negative 2 plus 3 is positive 1, so I get negative 6 as my limit. That x approaching negative 2 did not cause an issue, so I can use direct substitution for this particular one. It did not cause a problem, so I can just substitute it in and use order of operations and solve. Now let's look at number 11. So they wanted as x approaches negative 7. Well, if I plug in a negative 7 here, I have a problem. Negative 7 plus 7 in the denominator gives me a 0. And so I need to look at another way to possibly do this. Direct substitution is not going to work. The next method that I'm going to try here is by factoring and simplifying it, and then see if I can get rid of my problem. And so I have this limit as x approaches negative 7, and so I'm going to factor. So I'm going to factor this numerator. Don't forget there's a negative here, but you can just leave this kind of hanging out here. Factors of 21 that add up to 10, well, that is 7 and 3. So I have x plus 7 and x plus 3 all over that x plus 7. And now you can see those x plus 7s are going to cancel. And so now I have the limit as x approaches negative 7. Again, don't forget this little negative hanging out here. Negative, and then I just have the x plus 3 left. And now plugging in this negative 7 will not cause a problem. So now I can just plug it in. I have that negative out here, and then I'm going to plug in my negative 7 plus 3. Negative 7 plus 3 is negative 4, but don't forget you had that negative out there, and so that double negative makes that a positive 4. And so my limit here is going to be positive 4. So the second method is to see if you can factor and simplify to get rid of your problem. And then once you have gotten rid of your problem, you are just going to do substitution. Plug it in. Now, the third method we looked at was called rationalizing. Now, rationalizing usually stands out because, first, plugging in your limit causes a problem. Second, you see you have a radical. And so here they want us to go to positive 1. Well, positive 1 is going to cause a problem down here. And so factoring is not really an option there, so I am going to see if I can rationalize it. And so I'm going to rationalize this by multiplying the top and bottom by the conjugate of whatever has the radical. Here my numerator has the radical. And so the conjugate here is just going to leave that radical alone, change that from a minus 2 to a plus 2. And I'm going to do that on top and on bottom. Now, any time you multiply by conjugates, you get the same thing. You get the first thing squared, which is in this case is going to be a radical. Well, when I square the radical, I just get what's inside. I just get the x plus 3. And then you always subtract the square of the second one. Well, 2 is my second one here, so I'm going to say 4. That is 2 squared. So I squared the first one, and then I squared the second one. So you always take the first one squared, gets rid of your radical here in this case, and then subtract your second one squared, which gives me that. Now on bottom, nothing has changed, so I'm actually going to leave them grouped. I'm going to leave the x minus 1 like this, and I'm going to leave this conjugate thing by itself. I'm not going to FOIL or do anything with that. I'm going to simplify here the top. Now the top where I have gotten rid of my radical, I am going to simplify. X plus 3 minus 4 is x minus 1. So I have x minus 1 on top, and I have x minus 1 and this square root of x plus 3 plus 2 on bottom. Now you can see those x minus 1s are going to cancel. Now remember, when you cancel everything on top, you still have a 1. So I now have 1 in my numerator. And I have now just the square root of x plus 3 plus 2. And remember, I am doing the limit as x approaches 1. That no longer causes a problem. So now I can just plug it in. I can say I have 1 on top, plug in the 1, so square root of 1 plus 3 plus 2. Square root of 1 plus 3 is the square root of 4 plus 2. The square root of 4 is just 2, so I have 2 plus 2, which means I have 1 over 4. So my limit here as x approaches 1 is 1/4. And now we did infinite limits. So as we approach infinity, we're going to try to figure out what happens. Now in this first case, I have the same degree over the same degree. This minus 1 is insignificant because we are talking about infinity. If it is the same infinity over the same infinity, they really just cancel out. And I'm left with just those coefficients. I have a negative 2 in the numerator. That's a 1 in the denominator, so my limit here is negative 2, because those were the same infinities, so they just cancel each other out. And you're left with just what was the coefficient. Now, if you have something over here, we have a polynomial, these become insignificant because we're talking about infinity. And you just have to worry about what's happening with the infinity. Well, I am plugging in a negative. I plug in a negative here. So I'm basically taking this infinity and squaring it. Well, when I square a negative, this guy becomes positive, right? But it already had a negative in front. So that means the limit here is going to be negative infinity. And this is basically what you do with all of your infinities. If you have an infinity that is not being canceled out by something, then you just have to figure out if it's going to be positive or negative. If you have an infinity that is canceling out, it ends up being your coefficients. And so this is where you kind of run into deciding if the infinity is going to play a part or if it's just going to cancel out with something else. Or is it just going to be deciding, yes, it's moving towards infinity, but which one, positive or negative infinity? And of course, the other option is if you have something where the infinity on bottom is bigger, right? And so this guy kind of becomes insignificant, and this takes over. And so it really gets to be moving towards this little tiny number, which means it's moving towards a limit of 0. And so those are your three options. Either you have an infinity that cancels out with the same exact thing on top, and you just have your numbers. You have an infinity that just doesn't cancel with anything, and so you just have to decide if it's moving to positive and negative infinity. Or you have an infinity on the bottom that is bigger than anything else, and those always move to 0. Those are your only three options for infinite limits.